Okay, so welcome to the Intro to Earth Science. In Earth Science, there are four main areas: geology, oceanography, meteorology, and astronomy. In this class, we're going to be mostly focusing on geology because geo means earth, ology means a study of, so geology is really the study of the earth, and it's where several disciplines intersect into a concept known as Earth systems science. Earth system science views the planet as a series of systems that interact with complex relationships. The different spheres that we will look at in Earth science is the geosphere, which is the solid part of the Earth, the hydrosphere, which is the liquid water part of the Earth, the atmosphere is the gaseous part of the Earth, and the cryosphere is the solid water part of the Earth, and then the biosphere is where life occurs on the globe. So in order to get a good introduction to Earth science, it's important to know the structure of the Earth. So if we look here in these bottom two layers, this is the core. At the very bottom, it is the inner core. This is about 1,220 kilometers thick. It's completely solid due to immense pressure that it's experiencing at the center of the Earth. The outer core would be this layer right here. And this is a completely liquid part of the Earth. It's the only part of the Earth that is completely liquid. It is made entirely of iron and nickel, which circulates, and it creates the Earth's magnetic field. This layer is also important for keeping our atmosphere breathable. Because it's magnetic, it helps the water to not evaporate too quickly into the air, and it also protects us by deflecting the sun's cosmic rays and solar radiation. So the next layer is the mantle. The mantle is the largest layer by volume. It extends to 2,900 kilometers under the crust, and it consists of molten rock. So that would be this layer right here, the molten rock. And then there's a layer called the asthenosphere. Astheno means weak, and what this is like is kind of the consistency of asphalt. Because the rock isn't entirely melted, but it is soft, and due to a temperature variation, it moves kind of sideways and up and down, kind of like a lava lamp. And this is where the continents are kind of floating on top of, and that's where we get plate tectonic movements of the continents. So there is this boundary called the LAB, the lithosphere asthenosphere boundary, and that is where the mantle interacts with the crust. And then on top of that, we have the crust, where we have two labels of crust, where oceanic crust is underneath the ocean, and then continental crust is where the continents are. The crust is only about 100 kilometers thick or less, and if we were to compare the Earth to an apple, the crust would be thinner than the apple skin compared to an apple. So it's a very, very small part of the Earth. It only makes up about 3 to 5% of the total mass of the Earth. So the most fundamental view of Earth's material is the rock cycle. It tells us how matter is processed through the Earth and through the Earth's crust through a series of processes. We could begin here with magma. It's about 200 kilometers deep and about 600 to 1,300 degrees Celsius, where rock is molten and it turns into liquid magma. So from here, magma can form igneous rock through two different processes, an intrusive process and an extrusive process. So we'll go ahead and write that here. Extrusive is through volcanoes, so I'll represent that through kind of like a volcano. It can also come up through fissures in the ground, and when it comes up out of the ground, the magma is then called lava, and that can form what's called igneous rock. Intrusive is when the magma cools in the crust. It cools and crystallizes and forms igneous rock within the crust. So that is what an intrusive igneous rock is. From there, the intrusive igneous rock can uplift, which basically means that the rocks can come up to the surface. And igneous rocks can then undergo decomposition or erosion through weathering. So different things can cause weathering, such as rain or ice or even chemical weathering through acid rain, different processes that will break up the rock into sediment. So these are smaller particles that are forming from the breakup of the igneous rock. The sediments can undergo diagenesis, which are different chemical and physical processes that turn sediments into sedimentary rocks. This can include biofilm or mineral precipitation or just compaction as it has layers and layers on top of it and then being pressed under the earth, and that forms sedimentary rock. Sedimentary rock can then undergo what's called subsidence, where it's basically the rocks that are at the surface are sinking down into the lower parts of the earth, where it's experiencing extreme temperature and pressure. So I'll draw this arrow here, and this arrow is increasing temperature and pressure. Temperature and pressure. The farther you go down into the earth, the more temperature and pressure a rock experiences. And from there, it gets heated and pressed and twisted and stressed. And then it can change its chemical and physical composition, which forms metamorphic rock. Now, sedimentary rock can change into metamorphic rock, but also igneous rock can also experience subsidence and change into metamorphic rock. Metamorphic means just changing into another thing or changing shape. So that's what metamorphic rock is. From there, it could go to even farther down into the earth where it melts into magma. And then we see that process can start all over again, where it can form igneous rocks by extrusive or intrusive means, and then go through that cycle again. Or by uplift, metamorphic rock can also come to the surface of the earth and undergo decomposition and erosion. And I'll go ahead and label uplift here because that's what's happening. It's coming up to the surface of the crust. It can undergo erosion, decomposition, and weathering, and then turn back into sedimentary rock as well. So I have some examples. These are a sedimentary rock here. We have a conglomerate and sandstone, and these are just smaller sediments that have compacted into rock. We have a metamorphic rock, marble, and you can see that it's very dense. It has formed from high temperature and pressure. So I also have two examples of igneous rock here, pumice and obsidian. The more we understand about Earth's systems and the rock cycle and the different processes that matter and Earth's materials go through in order to form rocks, the more we'll be able to study rocks' individual physical and chemical composition and see that each rock has a story to tell. When we understand the processes that it goes through, it can tell us what pathway it took through the rock cycle. It can tell us how old it is, where it came from. It could even tell us about the climate of ancient areas of where it was formed and even living things. I think this is really interesting because when we study a rock, it's trying to tell us something. And when we understand it and can analyze it, we understand more how to interpret the story that it's trying to tell.